Hi all, welcome to our channel Electromer. In this video, we are going to learn about phase difference and phase shift. So this is our fifth video on the playlist of AC circuit analysis. We have learned that sinusoidal waveform is an alternating quantity. Mark this word, alternating quantity that can be presented graphically in the time domain along x-axis. So what does the alternating quantity mean? Alternating quantity mean with the help of y-axis the value of the x-axis, or with the help of the x-axis the value of y is alternating. It is changing with the time. So if we look deeper, this is a pure sinusoidal waveform. So here this sin x, this is the x-axis, this one is the y-axis. So when with the angle, with the increase of the angle, the value of the y is varying. So here at this initial point, the value is 0. Then till pi by 2 angle 90 degree, it is increasing. At this point it is reaches a maximum value, or another way we can call as peak point. Then after from 90 to 180 degree the value of the y is decreasing. At this point it is again reaches to 0. Then again it is increasing at the minus portion, then decrease to the 0. At this 2 pi it is coming back to the 0. So this is what we call as sine wave. The fraction of the time period that elapses in achieving certain instantaneous value is known as the phase of an alternating quantity. It can be expressed in angles. So these are a phase of the alternating quantity. So normally it can be expressed in two ways: pi by 2, pi, 3 pi by 2, 2 pi. These are what we call as radian format. In another way we can express as 90 degree, 180 degree, 270 degree, 360 degree. These are degrees. These represented in the degree form. So actually these are the angles. X-axis belongs to angles. Phase difference. When two alternating quantities of the same frequency attain their corresponding values, 0, maximum, minimum, simultaneously or simultaneous, they are said to be in phase with each other. So here we have to mark the word. When two alternating quantities of the same frequency attain their corresponding values simultaneous, then they can be said as in phase. So likewise, when two alternating quantities of the same frequency attain their corresponding values at different instant, when it is attained their corresponding value at different instant, they say to be out of phase with each other. So here are the difference between in phase and out of phase. This one is here there are two waves are indicated by two different colors. So the blue color and the red color. So here these two waves, when we can observe that it is attaining their corresponding value. This is the maximum point, this is the 0 point, this is the minimum point. So it is attain their corresponding values simultaneously. So for that one we can call as in phase. But here also it is attain their corresponding values at different instants. So here at this red phase or red wave at this point it is reaches the maximum value, but this blue wave at this instant it is reaches the maximum value. So there is a time difference in between two maximum point. So therefore these at this point, by observing this waveform, it is attained their corresponding value at different instant. That's why we can call as out of phase. So this is the example for out of phase. This one is a in phase. By out of phase means that two waveforms are not synchronized, that their peak and 0 points don't match up at the same points in time. The two waveforms shown above, A versus B, are of the same amplitude and frequency, but they are out of step with each other. In technical terms, that is called as phase shift or phase difference. So here there are two different waves. So first let's look at this one. Here this dotted line indicating one type of wave, and also another type of wave drawn by this blue line. So here you can see this dotted line wave reaches its minimum 0 point at this 0 instant, 0 degree angle, and it is reaches its maximum value at 90 degree angle. But this blue color or blue wave at this one is its 0 point, then it is reaches its maximum value at 90 degree angle. So it reaches their maximum point and 0 point and minimum point at different portion or different angles. That's why these are the out of phase. These are one type of out of phase. But here we have to note down is these angle difference we can call as phase difference. So here you can see that here also, here both wave has same amplitude, but at the different instant it is reaches its maximum value. At the different instant it is starting at the zero value. So same way it is reaches the minimum value at different instants. That's why these two different, in between these two instants, we call as phase shift. This is what we call as phase shift or phase difference. So here are four different types of wave patterns. Let's analyze each and every one. So for your clarification, I am writing this one here. The starting point of the A is something like this one. At this 0 degree angle, A is 0. Then it is reaches its maximum value at 90 degree angle. On that instant, B has 0 value. So for the assumption, at this point the angle is 90 degree. Then again it is decreasing to the, at this instant it is becoming as 0. So at this portion the angle would be 180 degree. 180 degree. So we can tell as the phase shift or phase difference. We can calculate the phase shift and phase difference. So phase shift, will be 90 degree. So the way I calculated the phase shift is, here at this instant A reaches its maximum value, but B reaches its maximum value at this 180 degree angle. So the phase shift will be 180 minus 90. That will be equal to 90 degree. That's why I have written as phase shift equal to 90 degree angle. Or another way we can express this one as A is ahead of B. A is ahead of B. Or another way we can tell as A leads B. A leads B. We can use the term leads. Likewise, when we consider this one is same as the first one, but the one and only difference is A shifted by B, B shifted by A. So here we can tell as the same phase shift. Here this one is also consists the same phase shift of 90 degree. But here B is ahead of A. B is ahead of A. Here A is ahead of B. Here B is ahead of A. Then another way we can tell as B leads A. B leads A. B is ahead of A or B leads A. So when we consider the third wave or third figure, here this is something like mirror image. Therefore, we can tell as A and B waveforms are mirror image of each other. But here the phase shift is here. Both has same zero instant. Both reaches same maximum value. Both reaches again same zero instant. So here this one A reaches its maximum value at this point and it is come to the zero, but this is minimum point. This is not a maximum point. For the B, this one is the minimum point. B reaches its maximum point at this instant. So at this instant B reaches its maximum point. At this instant A reaches its maximum point. So the phase shift will be 180 degree. Phase shift will be 180 degree. Be careful with the polarity. So this is the negative polarity or the negative portion. This is the this one is the positive portion. This one is the negative portion. So here this one is the negative portion. This one is the positive portion. We have to, when we consider the maximum value, we have to take these 2 points. When we consider the minimum point, A reaches its minimum at this point, B reaches its minimum at this point. So these 2 points we can consider for the minimum point. So this is something like mirror image, as I said earlier. That's why we can tell as A and B waveforms are mirror images of each other. Okay, finally here A and B are in same phase, same frequency, same amplitude, same instant. Therefore here the phase shift will be 0 degree angle, or we can tell as A and B waveforms are in perfect step with each other. A and B waveforms are in perfect step with each other. Mathematical representation of lead and lagging current. Normally when we pass the AC supply through resistive load, normally, as we all know, the AC will be pure sinusoidal waveform. So when we pass the AC supply through pure resistive load, then the output waveform will be in phase. The output sine wave will be in phase. As I said earlier, I hope you will understand that one. That will be in phase. But when we pass the AC supply through inductive load or capacitive load, there is a possibility for the lead and lagging in between voltage and current, something like this. So here this is the voltage waveform, this is the current waveform. So there is a phase shift or phase difference. That's why we call it as the out of phase. So here this is phi is the phase difference or phase shift. So normally we can tell as this is current. Current is leading by voltage. Therefore we can tell as the current waveform is leading by 9. For an example, I am considering this phase difference as 90 degree. Therefore I can tell as this current waveform 90 degree lead with. This current waveform 90 degree lead with this voltage waveform. Or other way we can tell as this voltage waveform lagging with 90 degree of current waveform. So I will explain you more deeper in coming tutorial. I hope you will understand the difference between lead and lagging. So thank you for watching this video. Please do subscribe our channel, and for the future updates